Hello friends, welcome to follow up. Let's have a look at problem 1027 again, longest arithmetic subsequence. In this video, again, we're going to explain a solution based on dynamic programming, but here the interpretation is slightly different. In the previous video, we used the difference subsequence length to do the dynamic programming. So here in this video, we're going to directly use the length of the longest arithmetic subsequence. So let's briefly look at the problem statement. So here we are given an array called nums of integers. So we are required to find the length of the longest arithmetic subsequence in nums. So here are three examples, which we will not go into details. And here the constraints are the following. The length is at least 2. And the elements are in between 0 and 500. So basically the constraints here give us an upper bound for the problem size. So with that said, let's first look at the solution, and then we're going to run through example 1 to give you a some digest or intuition. So in the previous video, we actually run through the two examples, example 1 and example 2. Here we just run through example 1. So here the interpretation is the following. So DPI difference. So I'm going to use this as length of the longest arithmetic subsequence ending at index at this number and with gap difference. So here I'm going to pass this using the tuple. So I def, right? So the reason is that the range of I is a priori known, right? This will be from 0 to the length of this nums given minus 1. However, the difference is not known a priori if we do not scan the list, right? So in other words, this part is for each I, so the diff is not a fixed size. So we use this one, we use a dictionary, and then we are going to find the largest keys. So first I'm going to write the code, and then we're going to run example 1 to give you the idea. So first I'm going to use a DP like a dictionary. So here I'm going to use collections default dict. So I'm going to set the values to be 1 if the key is not in there, or the default value to be 1 directly. So this is our DP initialization. So let me write some annotation. So DP initialization. So next we're going to do DP update. So for this, I'm going to first get the length of this nums. So this is just for convenience. And then we're going to iterate. So for I in range n, right? So the current number we're going to consider is this one, right? And then we're going to consider all the possible gaps. Consider the gaps or differences. So then we are going to for j in range I. So the gap for this one will be diff. It's going to be the current number minus the number at index and j, right? So what we are going to do is to check. So this one, so dp at this index, so j diff, it means the length of the longest arithmetic subsequence ending at index j, and the gap between them and the adjacent numbers will be diff, right? And then we are going to have this one, so dp, so I and get this diff will be this number plus 1, right? Because we can actually append in that corresponding arithmetic sequence the current number nums I, right? So the length is incremented by 1. So we can write like this. So here, because of our setting, we set the default value to be 1 if this key is not in the dictionary, so this will be 1, right? So if this because here is a tuple, we can write like this. This is fun. Or we can write, for some convenience, we can write dp I diff equals dp j diff plus 1. So here actually this is also a tuple, but it's just a short-headed writing. And then what we are going to do is to return the max dp values. So this is the current solution. So now let's do a test. Yeah, it passes one example. Now let's look at the generic case directly. Yeah, it passes all the generic cases. So now let's run example 1 just to get an intuition. So this, you can compare this run with the previous video. So initially, let's see the dp initialization. So we are going to have a dp table that is empty, right? And then we're going to look at this numbers. Notice that we use a default value 1 if a key not in, right? If we want to check a key. So here, when I equals 0, so we have 3. So there's no real work, right? Because there's no previous index for index 0. Then look at index 1. So current number will be 6, right? So we need to check j equals 0. So the diff will be current minus the value, that is 3. So we want to set dp. The index is 1, right? The gap is 3. So we want to set this one. It should be dp. So here we consider j equals 0, so 0, this gap, plus 1. But dp 0, 3 is not inset, so we're going to have 0, 3 equals 1. And then we're going to set this 1, 3 to be 1 plus 1, that is 2. So this is for index I equals 1. Now for index I equals 2, we have current equals none. So we need to check j equals 0 and j equals 1. So for this, the difference will be 9 minus 3, that is 6. So we want to set at index 2 and the gap is 6. So it's going to be the value at index j equals 0 and the gap is 6 and plus 1. And 0, 6 is not inside the dp table, so we're going to update this to be 0, 6, 1. And then at index 2, so 0, right? The gap is 6, right? 2, 6. So we're going to have 2, right? This is 1. So now let's look at this difference. This is 9 minus 6, that is 3. So we're going to set dp 2, 3. It's going to be dp. So here the index is 1, so 1, 3 plus 1. So 1, 3 is already inside, and it's 2. So we are going to have this 2, 3 equals 3. So this is for index I equals 2. Now let's look at I equals 3. So we are going to have current equals 12, and then we are going to check j equals 0, j equals 1, and j equals 2. So for j equals 0, we get the diff is 12 minus 3, that is 9, right? We are going to set dp 3, 9 equals dp. So here j is 0, right? We have 0, and the gap is 9 plus 1. So 0, 9 is not inside, so we're going to do 0, 9, that is 1, because we set this to be 1, right? And then we're going to have 3, 9 equals 2, right? And then for j equals 1, we have diff equals 12 minus 6. So we get 6. So we're going to set dp 3, the gap is 6. That's going to dp 1, 6 plus 1. So 1, 6 is not in the dictionary. So we are going to have 1, 6, that is 1. And then, so here we have 3, 6, that is 1 plus 1, that is 2. So now let's look at j equals 2. So we have diff is 12 minus 9, that is 3. So we are going to set dp 3, 3. That is dp, the current index 2, and the gap is 3, so we get 1. So 2, 3 is already inside, and the value is 3. So we are going to have dp 3, 3. That is 3 plus 1, that is 4. So by now we finished the run, and we want to do the return. The return will be the maximum value, so that is 4. So this is the run step by step. So here we can print out this DP to compare. So print this DP table. So we are going to have this one. So this is our run. This is the code print out. So let's delete this part. Just look at this dictionary part. We have 03 is 1, 13 is 2, 06 is 1, and 26 is 2, 23 is 3, 09 is 1, and 39 is 2, and 16 is 1, 36 is 2, and 33 is 4. It's in coincidence, right? As it should be. So with that said, basically that's about it for this specific problem and this form of solution. So we encourage you to run this code or run this step-by-step analysis for example 2 or example 3 to get a better understanding. So with that said, that's about it for this format of DP solution. Thank you.